Hello friends. As NASA and the private agencies prepare for the first crewed mission to Mars, a silent threat is evolving aboard the International Space Station. New 2026 research has revealed a startling reality. The near weightless environment of the microgravity is fundamentally reshaping how viruses behave, making them much more resilient, more adaptable, and potentially more powerful than their terrestrial counterparts. Let us explore this further. Mars, the next giant leap of humanity. We talk about the radiation that could scar our DNA, the vacuum that could freeze our lungs, and the sheer psychological weight of being 140 million miles from home. But as we prepare to send the first crewed mission to Red Planet in 2030s, a new invisible threat has emerged, not from the Martian soil, but from within the astronauts themselves. New research published recently in January 2026 has confirmed that the scientists long feared about this particular aspect. The space changes rules of biology. In the near weightless environment of the International Space Station, viruses aren't just surviving, they are evolving. They are becoming more resilient, more adaptable, and in some ways, much more powerful. Today, we are diving into the space superbug crisis. We look at the groundbreaking ISS study that's changing everything we know about the viral potency and why the journey to Mars might just be a 3-year trip in a high-tech petri dish. So, what happened? Let us explore this and discuss this further. On January 13, 2026, a team from University of Wisconsin-Madison published a study that sent ripples through the aerospace community. They weren't looking at human viruses yet. They are looking at the evolutionary arm race between a bacteria called T7 and the host, which is E. coli. Now, the bacteria is a virus that bacteriophage is a virus that hunts down bacteria. On Earth, this is a fast, predictable process. The viruses finds bacteria, injects its code into the bacteria, and then bacteria dies. But in the microgravity of the ISS, things got weird. Initially, the infection was slower because there is no gravity to cause the convection or fluid mixing. The viruses and bacteria didn't bump into each other as often. They essentially just drift. But here is the kicker. Once the infection finally took hold, the viruses don't just reproduce, they adapt. The study found that the space-borne viruses developed de novo mutations, genetic changes that have never been seen on Earth. These mutations made the viruses significantly better at binding to the host. They become specialists in harsh, stressful environment of the orbit. To understand why this is a threat to the Mars crew, we have to look at the physics of the air. On Earth, when you sneeze or cough, gravity pulls the large particle droplets to the ground in seconds. In microgravity, they don't fall. The study from the late 2024 modeled this behavior, and the result was terrifying. In space, a 10 micrometer particle, the kind that carries respiratory viruses, can remain suspended in the cabin for almost 16 years. On Earth, the same particle would settle in 8 minutes. This means that if one astronaut gets a space cold, the virus-laden particles don't disappear at all. They accumulate, they concentrate, and then the concentration of the viruses in the air can increase by nearly 300 times compared to the room on Earth. Every breath an astronaut takes on a long duration mission is a roll of biological dice. While the viruses are getting better at hanging around, the human body is getting worse at fighting them. This is the double whammy of the space travel. Decades of ISS data shows that the space flight suppresses the human immune system. our T cells and the natural killer cells, the special force of our bodies, become less effective. We have seen dormant viruses like herpes, Epstein-Barr, and Varicella zoster, reactive in more than half of the ISS astronauts. Imagine you're halfway to Mars, you are stressed, you are sleep deprived, and your immune system is operating at 60% capacity. Suddenly, a dormant virus in your system wakes up. Because you are in a closed loop air system, you begin shedding that virus into the air at 8 times the rate you would do the same thing on Earth. And because of the physics we just mentioned, the virus stays in the air for years. You aren't just sick, you're turning your entire spaceship into a viral hot zone. This brings us to the ultimate concern for the Mars 2030 mission. On the ISS, if an astronaut has a medical emergency, they can be brought back to Earth in less than 24 hours. In fact, just this month and in January 2026, we saw the first ever medical evacuation from ISS for a crew member. But on the mission to Mars, there is no abort button. Once you commit to the trajectory, you are gone for 2 to 3 years. If a virus mutation into something more potent, something that can bypass our standard vaccines or resist our antivirals, the crew is entirely on their own. We are talking about the possibility of the space pandemic inside a titanium tube millions of miles from the nearest hospital. This is the biosecurity is very important and number one priority for deep space mission. NASA is looking into real-time AI-driven genomic sequence to monitor the air for mutations and microbial mapping to track how hitchhikers, bacteria, and viruses are evolving on cabin surfaces. But it's not all bad news. There is a silver lining as well to this 2026 ISS research. By studying how these viruses become powerful in space, scientists have discovered how to use them against our enemies on Earth. The UW medicine team took these space hardened viruses and tested them against the drug resistant superbugs back home. They found that the mutations acquired in microgravity actually allowed the viruses to kill antibiotic resistant bacteria they couldn't kill before. In a strange twist of fate, the same evolution that threatens our astronauts might provide the key to curing some of the Earth's deadliest infections. Space is hostile frontier, and we are learning that the smallest threat might be the most dangerous. But as we push towards Mars, we aren't just learning how to survive in the stars. We are learning how to be better and survive better right here on Earth as well. The invisible threat is real, but so is our resolve to overcome it. And therefore, this is an important thing to remember, friends. If you found this deep dive into space medicine fascinating, hit the subscribe button. Let me know in the comments. Would you risk a 3 years mission to Mars, knowing a space superbug could be your co-pilot? Do let me know in the comments below. Thanks for watching, and I will catch you again in the next one.